So what is up, guys? Welcome back to me and Aiden's YouTube channel. We are at his lovely residence. As you can see, we're in nature, so it's gonna be a fun show.
And today with my co-host Noah, we will be exploring one of the most intriguing topics in physics ever, sun and stars.
First and foremost, the thing we need to know when it comes to sun and stars is the actual life cycle of a star.
The first step in forming the star is the stellar nebula. This is widely known as the birthplace of stars, and these are clouds of dust and gas drifting in space.
The next step of the life cycle is the protostar. After clumps of stellar nebula are pulled together, it forms into clumps contained with heat and pressure.
Palmer, Bellingham, Saka, Tony, Trent, pressure? What pressure?
The third step is the most well-known step, the main sequence star. Like our sun, this is the stage where hydrogen atoms start to fuse and release energy. This is the first point where gravity and energy are equal. As before, there was more gravity as the stars were forming and there was no hydrogen fusion. However, if a protostar is not heavy enough, then it will form a brown dwarf, as it will not be able to fuse hydrogen.
You may be asking yourself, what is a brown dwarf? A brown dwarf is known as a failed star. It is bigger than a regular planet, but is too small in mass to ignite into a full star. Alright, these next steps depend heavily on how much each star weighs. Lighter stars will become normal red giants, and heavier stars will become red supergiants. This is the point where stars run out of hydrogen to fuse and start fusing larger elements. There is now more energy than gravity.
If the star is a red giant, its outer layers drift away, and what is left is a white dwarf. They will glow hot for billions of years, then cool down into a black dwarf. Since it's only the core, gravity and energy are once again equal.
But if the star is a red supergiant, it will run out of materials and explode, creating a supernova. Here, there is much more energy, and these explosions create materials for future stars to form.
What happens after a supernova depends on whether a star is more or less than 20 solar masses.
Solar masses are how much heavier or lighter a star is compared to the sun.
If under, the remains is a neutron star, which is a hot, dense core left over where gravity and energy are again equal. If over 20 solar masses, a black hole will be formed. Gravity is so strong here that not even light can escape.
Adding and subtracting elements is very simple. When adding and subtracting them, focus on the atomic number, the pound symbol, and the number of protons plus neutrons.
All you have to do is add or subtract the number of protons, neutrons, and the atomic number, and based on the atomic number, that is the element that is produced.
Also, when considering the element that is produced, you must include the numbers with alpha particles and beta particles, which are leftover radiation from heavy elements.
Another aspect of sun and stars are nuclear fusion reactions. Let's dive into a little bit of chemistry.
Everything in this universe is made out of atoms, and for stars to develop, they must fuse atoms.
Fusion continuously happens as the star grows, and as these atoms get larger, the number of protons and mass goes up. When determining the life cycle of a star, all we have to do is look at the solar masses of that specific main sequence star.
For example, Alpha Centauri A, a main sequence star, has 1.1 solar masses, meaning that since it's between 1 and 8 solar masses, it would become a white dwarf, then a black dwarf.
Other options are if a protostar has less than 1 solar masses, think about it like this blitzball right here, then it would become a brown dwarf. And if a star is between 8 to 20 solar masses, think about it like this 10-pound dumbbell right here. It would become a neutron star after its supernova. And if the star is over 20 masses, think about it like this big dumbbell here. it would become a black hole after its supernova.
So that about wraps it up. Me and Aiden have covered all you need to know about suns and stars. Now that you have mastered the stellar life cycle, nuclear reactions, and mass and energy relationships, you can now apply to Harvard, work for NASA, or win your family trivia night.
Thank you guys for watching. Do not forget to subscribe and keep up with the channel. Until next time.